Welcome to today's explainer. Look, today we are flying at maximum altitude. Think of this explainer as your advanced top-tier aerial combat training for tackling the absolute toughest, most mind-bending questions the Cambridge physics syllabus can possibly throw at you. Our primary target today, we are mastering the complex physics of the expanding universe. And more importantly, we are decoding the exact, precise methodology you need to absolutely ace your next exam. Now, to set the stage, I want to introduce you to two students who recently took on this exact mission. Let's call them Alex and Sam. They were faced with a real Cambridge physics past paper question, specifically from code 0625. And honestly, they both crashed and burned, but for completely different reasons. Alex, for instance, just overloaded the page with raw physics facts. They were just dumping everything they had ever learned about the galaxy, the stars, the planets, all of it, without any tactical analysis whatsoever. It was just a wall of text, and let me tell you, the examiner's red pen was absolutely merciless. Sam, on the other hand, went the complete opposite route. Sam rushed through it, panicked, and completely missed the specific command word requirements in the prompt. So Sam ended up losing massive marks on questions they actually knew the answers to, all because of poor execution. Today, we're going to put their flawed answers right under the microscope. We are going to transform those brutal red marks into beautiful green check marks, and I'm going to equip you with the ultimate tactics to secure full marks. Okay, let's get right into it. So here is the big one. How do we calculate the exact age of the universe? This is literally the million-dollar question. It perfectly bridges the gap between the grand, awe-inspiring scale of theoretical astrophysics and the incredibly precise, rigorous mathematical calculations that your examiners are aggressively looking for. When Alex faced this specific prompt, they wrote what I can only describe as a beautifully poetic essay about the stars. It belonged in an English literature class, honestly, but they earned absolutely 0 marks. Why? Because they completely failed to provide the required mathematical proof. Sam, trying to be quick, just scribbled down a single number without showing any of the foundational steps, and immediately lost half the available points right out of the gate. Listen to me carefully. To get that A-star, you must execute a perfect tactical maneuver. You have to demonstrate your deep understanding of the cosmos, but you have to do it while strictly, and I mean strictly, adhering to the technical assessment objectives of the exam. You have to play the examiner's game. Here is our flight plan for today. We'll start with the expanding universe, move into the Hubble constant math, calculate the age of the universe, break down the technical exam methodology, and finish up with top examiner warnings. Section 1. The expanding universe, evidence of a single point. To truly grasp the expansion of the universe, we first have to look at the foundational evidence that literally all matter in the universe was once present at a single, incredibly dense point. This core principle of the Big Bang Theory is a massive, high-value target on your exam. When a question asks you to outline the evidence for the expanding universe, examiners absolutely do not just want you to write, "Oh, the universe is getting bigger." No, they want you to expertly explain the mechanics behind that expansion. Notice how the two critical variables examiners hunt for are broken down right here: speed and distance. Speed, which we represent with the letter V, is derived from wavelength changes. We're talking specifically about the red shift of light from distant galaxies. As a galaxy moves further away from us, the light waves stretch out, shifting dramatically toward the red end of the electromagnetic spectrum. It's like a visual Doppler effect. Then we have distance, represented by D. This is determined using supernova brightness. Specifically, astronomers look at type Ia supernovas. These act as standard candles because their intrinsic true brightness is a known mathematical constant. This allows us to calculate exactly how far away they are based purely on how dim they appear from our perspective on Earth. Now, to write a perfect answer, we use the Peel framework: point, evidence, explanation, link. Think about Alex and Sam again. Alex wrote, "Galaxies are moving fast. We know this because of redshift and supernovas are bright." 0 marks, no structure. Sam, however, learned the Peel framework and wrote, "The universe is expanding. We observe redshift in distant galaxies. This wavelength change indicates galaxies are moving away with speed v, while their distance d is found via supernova brightness. Therefore, this simultaneous recession of all galaxies links directly to an origin from a single point." That is a flawless, top-tier answer. Before we continue, subscribe to our YouTube channel, AC Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving on to Section 2, the Hubble constant math, the core equation. Let's shift gears from theoretical astrophysics into hard, undeniable mathematics. The absolute crucial takeaway here is that the Hubble constant simply represents the speed of a galaxy divided by its distance from Earth, so h0 equals v over d. This right here is the transformation phase of our explainer. I want you to visualize those red pen marks turning into green check marks. Earlier, Alex completely panicked and just dumped the formula onto the page without defining any of the variables. Sam somehow inverted the ratio entirely and wrote d over v. Total disaster. By applying our physics success blueprint, we can instantly transform those critical errors. The blueprint dictates that you must explicitly, without fail, state what the letters mean in your working. You write the equation h0 equals v divided by d. Then you write where v is the recessional speed of the galaxy in kilometers per second, and d is the distance in megaparsecs or light years. By explicitly defining this ratio, you lock in the knowledge marks and the application marks. You are literally forcing the examiner to give you points. Let's do a quick mental exercise. Imagine a 60-second timer ticking down in your head right now. If you were handed a blank sheet of paper, could you write out that equation and explicitly define both variables under pressure? That is the level of speed and accuracy you need to cultivate.
Now, I need you to burn this specific syllabus figure deeply into your memory, because the current accepted estimate for the Hubble constant is 2.2 times 10 to the power of negative 18 per second. Let me say that again, 2.2 times 10 to the negative 18 per second. This isn't just some random number pulled out of thin air, it is the exact, specific figure the Cambridge marking scheme requires for syllabus code 0625. Listen, if you go and use an outdated figure from an old textbook or something you read in an article from 5 years ago, you will immediately lose the accuracy mark. Examiners are ruthless about this. You have to keep your focus strictly on this syllabus figure. Don't let a tiny detail like a textbook edition be the reason you drop a grade boundary.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's jump into section 3. Age of the universe. Time is distance over speed. Let's see how we take this ratio and creatively flip it to solve for time. Let's run an interactive workshop right now. Imagine a complex data table flashing on your screen right now, showing the speeds and distances of 5 different far-off galaxies. You have a 60-second visual countdown timer ticking away. Your first challenge, data scan. You need to extract the core trend from that table instantly. And the trend you need to spot is that as distance increases, speed increases proportionally. Okay, challenge number 2, find the flaw. Listen to this sample paragraph from Alex and tell me exactly where they lose the mark. To find the age of the universe, you divide distance by speed, so the age is v over d. Did you catch it? Alex stated the correct English principle, distance over speed, but then wrote the wrong algebraic fraction. They wrote v over d instead of d over v. It's a classic panic mistake. Now for challenge 3, speed writing. You have 30 seconds to write down the flawless derivation. Ready? Here it is. Step 1, you write the constant, h0 equals v over d. Step 2, you recall basic kinematics, time equals distance divided by speed. Step 3, you derive the formula, therefore age equals d over v. And since h0 is v over d, the age is simply the reciprocal, 1 over h0. Boom. Showing these 3 exact steps clearly and sequentially is your guaranteed foolproof pathway to securing full marks. You are leaving absolutely nothing to chance.
Section 4. Technical exam methodology. The examiner's lens. Now that we have the hardcore physics and the complex math nailed down, it is time to translate this conceptual knowledge into top grades using exact, repeatable procedural frameworks. I need you to really internalize this quote. Never, ever underestimate the method mark strategy. As direct Cambridge principal examiner reports consistently highlight year after year, showing your analytical process is your ultimate insurance policy for your final grade. Think about it. Let's say you do everything right. You perfectly derive 1 over h0. But then when you type 2.2 times 10 to the negative 18 into your scientific calculator under extreme sweaty palms exam pressure, your finger slips and you miss a 0. Your final answer is completely mathematically wrong. If you only wrote down that final answer on the line, you score a flat 0. Game over. But if you wrote out the 3 sequential steps we just reviewed right above it, the examiner will look at your method, see you understood the physics, and you will receive 2 out of the 3 available marks purely for your method. Method marks are your safety net. Do not fly without them. Okay, look at this table. This sequence is your ultimate cheat sheet, your master blueprint for tackling wildly unfamiliar contexts systematically. This ensures absolutely 0 marks are left on the table. This is the complete physics answering system. I'm going to give you the 3 unbreakable rules that guarantee top marks. Rule number 1, command word decoding. You must deconstruct the question first. If the command word is calculate, that means you must show numbers and formulas. If the word is explain, that means you must use the Peel framework we talked about earlier. Rule number 2, Peel framework application. You extract data from the provided tables, select the right analytical framework, and integrate it into your point, evidence, explanation, and link. Rule number 3, time management matrix. You execute your math and present your final answer swiftly and clearly. Just look at the sequence: deconstruct, extract, select, execute, present. If you memorize this exact workflow, you will systematically process literally any astrophysics question thrown your way. You'll be effectively flying at maximum altitude without burning out your engines. Notice the massive contrast in approaches here. Standard, middle-of-the-road answers act like the Hubble constant exists in a total vacuum, completely separate from the rest of physics. But top-scoring, elite answers demonstrate high-level evaluative thinking. Principal examiners constantly highlight that anchoring your astrophysics knowledge to other areas of the syllabus is exactly what elevates a response to the top tier. And honestly, whether you are studying syllabus code 0625, 0651, 0652, 5054, or 9702, cross-topic connection is king. It rules them all. For instance, linking the redshift of distant galaxies back to the fundamental physics of the Doppler effect, or tying it into the specific properties of electromagnetic waves, shows a profound, deeply integrated understanding of the subject. It shows the examiner you aren't just blindly reciting a textbook. It proves you are genuinely thinking like a real physicist. Section 5. Top examiner warnings, pitfalls to avoid. Let's expertly navigate safely around the exact areas where thousands of students unnecessarily drop easy marks every single year. You absolutely must avoid these 3 most common mistakes by rigorously double-checking your presentation and tying your physics calculations specifically to the context of the question. First up, forgetting proper format. If you calculate the incredibly complex age of the universe, but you forget to specify the final unit, whether it's seconds, years, or millions of years, you will drop a mark. It's tragic, but it happens all the time. Second, failing to check overall presentation conventions. Listen, examiners hate messy, chaotic, unstructured calculations where the logical steps jump randomly all over the page. Use clear, deliberate annotation. Line up your equal signs vertically. Make it easy for them to give you points. Third, providing generic answers. This is a big one. If the exam question gives you a specific data table about, say, the Andromeda galaxy, and your written answer just casually talks about galaxies generally without ever referencing the specific numbers or data provided for Andromeda, you are immediately losing context application marks. You have to use what they give you. Look, cognitive load during an exam is incredibly real. Creating a simple mnemonic can ensure you never drop these easy marks under the intense pressure of a ticking clock. Take the first letters of our blueprint: deconstruct, extract, select, execute, present. DESEP. Make up a weird, memorable phrase that works for your brain. Seriously, do it right now. When you successfully combine these psychological memory hacks with the deep, technical, conceptual understanding of things like redshift and standard candles that we discussed today, your mark potential literally skyrockets from 0 to 100%. You become unstoppable. So the tactical blueprint is entirely in your hands now. You know the underlying physics, you know the exact math, and you know precisely what the examiner's red pen is desperately searching for. The only question left is, when you look up at the expanding night sky, are you just seeing pretty stars, or are you seeing the exact mathematical proof that will secure your future? Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.